All right, folks, here we go. 7.5 scale drawings. So you have your warm up right here. So if you want to push pause, feel free to do so. But we're solving proportions. When we solve proportions, we just go numerator times denominator. Sorry, denominator times numerator, denominator times numerator. So we end up with 9x equals 8 times 27. 216 divide by 9, and we get x equals 24. All right, again over here, sometimes you can reduce them to make them friendlier numbers. So we have 2 and 7, and so now we have 7x equals 70. See, I can do that one in my head, otherwise I couldn't have x equals, oops, 10. All right, again over here I see that there's one group here, excuse me, two groups here, and that's divided by 4, and so 9 groups here, and so we have 9x equals 180, divide by 9, divide by 9, x equals 20. All right. 1 and 4, make it easy on ourselves, so we have x equals 28. And over here, again, make it easy for us. We can divide by 2, so we have 10 sevenths. So we have 7x equals 560. How did it get that so fast? 10 times anything, just add the 0 to the end. Divide by 7, divide by 7. 56 divided by 7 is 8, so x equals 80. All right, looking over here, we have 9 groups of 2. 9 groups of 2, 2 groups of 2. 18 times 9 is 162, so 2x equals 162. Divide by 2, divide by 2, and x equals 81. All right, moving on. Today we're looking at how you can enlarge or reduce a drawing proportionally, right? So if you have, say, 1/2, and you're moving it to 1/4 the size, right? We need to basically divide by half, right, in order to get to 1/4, right? So we're going to talk about how we do that proportionally today. So key ideas: scale drawing is a proportional, it's a key word there, proportional, two-dimensional drawing of an object. A scale model, right, model versus drawing, is a proportional three-dimensional object, right? The measurement in scale drawings and models are proportional to the measurements of actual objects. The scale gives the ratio that compares the measurements of the drawing or model with the actual measurements. Now I'm going to post a video for you as well, just a video clip of one of my favorite movies that has a really cool kind of way to help us realize scale drawings and models and so forth, right? And so we have this idea, it's 1 inch on the actual drawing, but the actual distance is 10 miles, right? This might be maps. I know we all use Google Maps, but we used to have to pull out a paper map and used to have to use a guide to see, okay, how many miles this would be. So going somewhere would be a planned out trip. Ask your parents about it, and they can maybe show you a map they might have stowed away in their glove box from way back when. I still have some from when I first started driving. So again, the first unit is the actual from the drawing, and the second unit in the ratio is the actual distance, right? So on the map, it'd be 1 inch, right? So it would be like 1 inch, but every 1 inch on the map would be 10 miles. So 1 inch, 10 miles if you had 2 of these, right, you would have 1 inch, 10 miles. So for 2 inches, we go 20 miles. All right, move forward. So we did this yesterday, and for time's sake, I'm not going to go through these, but if you had any trouble with these, we either can talk about it together or you talk about it with some of your friends and whatnot. But this was Monday's assignment, so I'll go ahead and fast forward through here. I broke it up into 2 days. All right, so we're actually, what is the actual distance between Cadillac and Detroit, right? So here's Cadillac, right? And here is Detroit, right? So now what you could do is you could take this guy right here, cut it out and do your measurements. Okay, there's 1 here, 1 here, 1 here, 1 here. It's not that accurate, right? So our accuracy would suffer. Right? So there's a mathematical way. And so we set up this formula, right? And then in your notes from previous, it talks about these different ratios, okay? And so what I want to go through here with you is to write that ratio out. So 1 moment. All right, and so what we're going to do is we're going to use a proportion, okay? And we have our scale, right? So that's good. Oops. Something's going on here. All right, so we have our scale, right? All right, and from our scale, we're going to use that. So we have 1 centimeter over 50 miles. For every 1 centimeter on this map, it's 50 miles in real life. And then we're going to come over here, and we're going to match up our map distance over our actual distance, right? And so when we plug in these numbers, what we are actually missing is the actual distance. Now, where do I find my map distance? Well, you got to take out a ruler, okay? And so what's going to happen here is you're going to actually take out a ruler and you're going to measure how far it is from Cadillac to Detroit. Okay, so we need to measure this distance. All right. And so I have done this already for us, and our map distance is 3.5 centimeters, right? So if you put a ruler up there, and you would say, so 1 centimeter over 50 miles equals 3.5 centimeters. And where did this come from? I measured this distance with a ruler. Okay. And then I have my actual distance, which I'm trying to find. Okay, and that's going to be in miles. And so you might wonder why we were doing that type of warm-up this morning. This is the reason, because we're going to be practicing proportions. So we have 1x, right? And so we have 50 times 3.5, and we have 175. So we have x equals 175 miles. Where did 175 come from? Well, it came from multiplying 50 times 3.5. That's where that answer came from. If we had something attached to x, we would divide, obviously, but this is a one-step equation. And so alright, so the actual distance would be 175 miles from Cadillac to Detroit. Alright, so this one's for you to do on your own. Go ahead and pause if you'd like to watch or do on your own. But I'm going to do it now. But again, if you would like to try on your own, make sure you push pause. All right, so what is the actual distance? Trying to find the Traverse City to Marquette, right? So looking from here to here, right? Now, we can't drive across water, but we're going to look like, well, how far is it from each other, right? We would have to go this way to this place, but we're not going to measure this. We're just going to measure from here to there in a straight line, right? So again, you'll need to take out a ruler. And how I'm using my ruler for you to kind of just see this is for you to, with my line. So we'll take a ruler, we'll measure from here to here, and go from there. So, okay, go ahead and push pause if you need to. All right, so here we go again. I decided to look up something really fast to make sure I was on the right track. So this is about, let's say about 3.4 centimeters, measured from my book. So I'm not sure about the one on your page, but again, you're gonna have to measure this, and it might be a little different from what we had, right? And so we're actually going to use the formula, and we're gonna basically say scale over actual equals scale over actual. We're going to set up two proportions equal to each other. Okay, so now we're going to look at, okay, well, what did it give us? It gave us part of it, right? So that's going to be one of ours. So 1 centimeter over 50 miles. Yeah, so same scale factor as we had before. And we're actually looking for the actual distance, right? So we know that it's going to be over x. And then we have to actually measure this distance, and I'm going to put 3.4 in here for mine, but if you measured something different, yours might be a little bit different. And I'll tell you at the end how we go about answering these types of questions, right? So we do a cross multiplication. All right, and so we say, okay, well, 50 times 3.4, 1 times x. So we have 1 times x on this side, and we have 3.4 times 50 on this side, and say 3.4 times 50 equals 170, so x equals 170 miles, right? Now, say you rounded this, right? You say an even Steven 3, okay? So you might get around 150, right? And so what we typically do, we say x, excuse me, the distance is about 170 miles apart, right? And so we use this word about, means that we could have measured it a little bit different. If you measured it 3.3, it would be different. If you measured it 3.5, it would be different, right? And so in the BIM assignments, they'll actually provide you a ruler. And so just make sure you try your best to match up that ruler. You can move it around the screen. In fact, I have one up right now. I can kind of show you that screen so we can, right? So this is a problem on one of the reviews. We have this little ruler box. A ruler pops up. We can move the ruler wherever we want. We want to measure this little segment, right? We can put it right on the top. We'd say that's about 6 centimeters, right? You can see 1, 2, 3, 4, 5, 6, right? We want the ruler to go away. There it goes. All right. All right, moving along. So the liquid outer core of the Earth is 2,300 kilometers thick. A scale model of the layers of the Earth has a scale of 1 inch for every 500 kilometers. So we have 1 inch. One of our ratios is 1 inch over 500 kilometers, and we're going to match up our units, right? So we need kilometers down here, and we need inches up here, right, to match up with our inches on top and kilometers on bottom. And so it says, how thick is the liquid outer core of the model, right? And so we have how thick it actually is, okay? And we're looking for the model, right? So this will be our x here, and we'll use 2,300 right there. This is where our calculator is going to definitely come in handy, right? So we have 500x equals 2,300 divide by 500 divide by 500, and x equals 4 6/10 inch, right? And we see that that is going to be answer B. You're going to use the same idea, so you're going to be remember this for the next time, for next page. You're going to do one on your own. Again, push pause if you'd like. It says how thick is the mantle of the model, so we know that's going to be in inches. So we're going to look for that in something inches. We're going to use 2,900 kilometers. We have 1 inch equals 500 kilometers. Where did I get that? That was from the previous question. It told us. And we're looking for X inches. And this is saying that the mantle is 2,900 kilometers thick. So we'll do our cross multiplication. So we have 500x equals 2,900 kilometers. We're going to divide off here. Right, and so 2,900 divided by 500 equals 5.8 inches. Right, units are going to be very important, so do not forget the units. Right, if you put 5.8, it would be marked wrong. I'm not sure on the Big Ideas Math if it will tell you the unit or not, but make sure you double check that. Okay. So scale model of the Sargent Flood Monument is 10 inches tall, so that we know it's a model. Right, so we have this person. Right, this person is model is 10 inches tall. Okay, so what is the scale of the model? It says the actual is that. So we have the model divided by the actual. And that will give us our scale model. So scale model, it gave it to us this last time, right? It says the scale is 1 inch for every 500 kilometers, and this is actually what we're figuring out right now. Okay, so we're going to use this that formula of the model height over the actual height. So we have 10 inches over 100 feet, right? So just another ratio of feet, and we know that it's a 1 to 10 ratio. 1 inch for every would equal 10 feet, right? So this would be our scale model. And then now we're going to, what is the scale factor of the model? And so scale factor, now we're just going to use that, and we need to use the same units, right? So the scale factor just means put into same units. So you might think about that activity yesterday and how that kind of was asking you to do that. So we just have to use a conversion factor. So we're going to say that for every 1 inch, right? Sorry, not going to be equals. We're actually going to multiply this, right? Because we say that 1 foot equals 12 inches, and we want our feet to cancel out, right? And so what you'd have 1 inch times 1 foot over 120 inches times feet, okay? And we see that inches crosses out, inches, right? And we end up with a scale factor of a 1 to 120, right? So I guess I should say put all the same units, right? We need to convert, not convert, we need to cancel our units out, right? And so let me erase that. So I just kind of said that wrong. What we really want to say is we want to cancel out units. Okay, so we use the conversion factor. Where did this come from? Well, that's real life. A ruler is 12 inches long, also known as a foot, right? 12 inches equals 1 foot. Okay. All right, so this one's on your own. Push pause if you'd like. Otherwise, go and follow along with me. A drawing has a scale of 1 millimeter for 20 centimeters. What is the scale factor, right? So scale factor, no units, right? So when you get rid of these units, so 1 millimeter over 20 centimeters, right? And so we know that, did it again, multiply. Multiply, right? We want our millimeters to go away, so I know that in 1 centimeter, there are 10 millimeters, right? And so I can see that millimeters will cancel out with millimeters, centimeters will cancel out with centimeters, and we have 1 times 1 on top, and we have 10 times 2 on the bottom. So our scale factor is 1 to 200. Okay, 1 to 200. That got kind of out of hands. A little smaller. Sorry if that's covering up some of the things on yours. You can see here now. The scale drawing of a computer chip helps you see the individual components of the chip. All right. Find the perimeter and the area of the computer chip in the scale drawing, right? So we have, to find the perimeter, right? All right, I reviewed that last problem, and I just didn't really feel like it was necessary for us to do, so I took it out. But you have a closing thing right here. So find the actual dimension. The scale is 1 centimeter to 4 feet, right? And so we say 1 centimeter over 4 feet. You're going to be setting up a lot of proportions here. And centimeters are going to match on top. 7 centimeters over our x feet. Cross multiply those out. We have x equals 28 once you finish. And then 1 centimeter over 4 feet equals 10.5 centimeters, again matching up my units. X feet, so 10.5 times 4 equals 42, so we have x equals 42, and then so forth. So I'm going to go ahead and pause this. I'll do those and let you do them all right, so here we go. One thing to notice is that it gave us meters here. I actually didn't notice that until the very end. And actually I just realized up here that it gave us millimeters, so we're going to have to redo this one as well. So I'm going to work on redoing this one. So this is not the correct answer here. And I'll rework on doing that one right now for you. So as you can see, folks, I actually did number 4 incorrect. Basically, in order to transfer, I need to convert my 19 millimeters to centimeters, because that's what's given me in my scale unit. You can also change this to millimeters, but you'd also change the feet because it helps to be different. But easiest thing to do is set up a conversion factor, which 19 millimeters times 1 centimeter over 10 millimeters, because 1 centimeter is 10 millimeters, and so we have 19 divided by 10, which equal 1.9. Set up your proportion, cross multiply, and you get m or x equals 7.6 feet. Again, down here, my 0.4 meters equaled 40 centimeters, right? Because I multiplied by 100, so I need to move that over 2 decimal place values, right? And so I end up with 40. Over here, 4.25 times 100 would equal 425 centimeters. And go from there. All right. Have a great one. Make sure you do your Big Ideas math assignments that has been posted for you on the portal.